Okay, so I'm happy to be able to have a second presentation here, talking a bit more about activities in the company, my company, Prediktor, TGS Prediktor, and some examples from the project we've done with clients using OPC UA basically for a use case that services the enterprise of our clients, not the specific plant, but we mostly target to be a system that can act as the mediator from the plant systems to the IT systems, like highly scalable OT-IT gateway. But first, some of the motivation for this, and I will, in this time, I'll use an example from solar PV operations, utility scale solar PV operations. First, this asset behind here is visible from the outer space. If you go to Egypt and go to the Aswan Dam there, you will find this asset only a few kilometers from the riverside. So it's the Benban Solar Park. When it was built in 2019, it was the biggest solar park in the world. Now it's not the biggest anymore. It's 1.8 gigawatts of capacity. So it produces the same amount of energy as the Aswan Dam in Egypt. Scatec is the biggest operator in the solar park, and Scatec is one of our clients. But Scatec has a portfolio of utility-scale solar assets. And what does it mean to own a portfolio of utility-scale solar assets in the technology? I'm now first addressing part of the challenges. So we're talking about asset management. That means the activity where you're sure that your asset is performing as good as possibly at all times. You're looking at the asset, you're figuring out what is the deficiencies. Does it produce according to capacity, or are there some equipment not operating as it should? So you have an enterprise and you have a portfolio on a range of sites. Now, the ability then to onboard and adopt new methods and technologies is essential. There's a continuous evolution here. So what we're talking about right now are the technologies like virtual asset hybrid. We're talking about drone inspections, portfolio optimization, energy storage, artificial intelligence. These operators are looking at new methods of trying to enhance their operations continuously. So their ability to onboard new technologies and scale out in the organization is essential. So I will claim that especially these younger industries, they are still in the infancy in terms of big industrial scale operations, so there's a lot of things to do here. Challenge though is that in order to keep the prices down, when they build the assets, they have local suppliers that they select to do the configuration and the setup of the equipment. Net result of this is that you will have a lot of different configurations of the equipment. You have different inverter suppliers, you have different module suppliers, you have different organizations doing the EPC and the tagging and the setup of the equipment. Hence, the net result of this is that the data streams coming out of these assets looks very different. So kind of like you can say they have kind of like different colors. Of course, you could try to standardize on suppliers. This is challenging when you operate on a global scale because not all suppliers will have offerings all across the globe. And also, it's not a good idea because it will bring you into a lock-in situation. So this is a very competitive area, so the cost is coming down all the time if you can choose and put the suppliers up against each other. But then if you want to scale out the technology and you have different suppliers across all here, then you have a deep and detailed integration on each specific assets when you want to scale these out in the enterprise. Hence you have manual integrations and typically with N new technologies you would like to have, and you have M assets, you have N times N M integration activities. So this is back to the integration hell that we know from a lot of the industries. So what can you do on the enterprise? Okay, you can also standardize on the local SCADA. choosing a local SCADA provider, and then have a standardized data stream up there. Again, you're then vulnerable to become in a lock-in situation with that SCADA supplier. And what we see more and more is that there's happening a lot of consolidation now in this space. So the asset play is ongoing. Companies would like to sell out assets. They would like to buy other assets, and they would like to bring it into the enterprise strategy. So the challenge needs a solution. And of course, information models is an essential kind of like strategy to look into for enterprises like this. So, and what is good now is with PV scale, utility scale PV solar assets, they have more or less the same structure in terms of how they build their assets across. You can identify the different equipment types that is generally there, and then you could set up all those equipment types, and you set up the natural structure and interconnections between them, and voila, you have an information model. So these equipments are kind of like classified types, so you will find these in all kinds of assets. It's not an enormous amount of equipment types, and so there's a good chance to standardize this. So then the opportunity is then to bring this into the SCADA system, or put that on top of the local SCADA, and ensure that whenever you will bring data up to the enterprise, it will always be mapped to the standardized asset types, the equipment types in this information model. So then there's most likely that deploying a new technology will become much more plug and play, because you will see the same definitions for any type of equipment across. Now, I mentioned Scatec as one of the leading utility scale operators in the space. It's a Norwegian-based company. They have 4.6 gigawatt in operation and under construction, more than 700 employees in 26 countries. I mentioned the impressive size of Benban. So this is one of more than 40 different assets that Scatec operates across the globe. So our deliveries to Scatec has been data capture on the edge. We then have the industry data gateway that does the data collection on everything that comes from the asset. And actually now with on one specific asset, I showed you earlier today the number of projects and the size of gigawatt. And if you do the math there, you can see that the average size in the utility scale solar now is 300 megawatt new projects. These are huge constructions. In a 300 megawatt utility scale solar plant, you have about 1 million solar panels. And each panel has one sensor, potentially. So there's a lot of data coming out of these assets. So we set it up. This side, there was 36 sites. We have counted about 2,000 point-to-point connections to all the equipment across the enterprise. And then all kinds of different protocols towards the equipment out there. We have Modbus, OPC Classic, UA, various types of IC communication specification. So you find all of this. So all of this needs to be up and running all the time. So when it's collected then up to the enterprise, a year ago we counted 1.75 million signals with real-time values, time series, alarms, and events. And so you can expect that managing all of this on top here is a challenge. Because this company has decided that it will have one central organization based in Cape Town, South Africa, to actually operate all of those 36, no more than 40 assets. And they will like this organization to be able to take on more and more responsibility. They remove people from the local site because they can do the management from the central site. That's a way to save cost. And then they would use an analytical team in Oslo to analyze the data across all sites, identify best practice, do new optimizations on how to detect anomalies, etc., to automate drone inspections, automate maintenance orders. All of this becomes autonomous eventually. And of course, the ability to take in new assets into this, even though it's been built by others. It's only a remapping to be done here, and then voila, everything works otherwise on the enterprise side. So this is how this operating room looks.
The competition is getting much stronger.
And this is the client statement about the system.
Prices are dropping, so it's about finding a way to optimize our plant efficiency and reducing the cost by analyzing and using the data that we have available from our plants.
Each solar plant generates thousands of data points, which are streamed to a Global Control and Monitoring Centre, or CMC, in Cape Town, which monitors events and ensures appropriate data quality. A team of analysts based in Oslo then work on developing new methods for data filtering and production loss detection. These methods are then used to develop actionable insights at the Control and Monitoring Centre. Combining advanced data analytics with field operations, the project has developed a novel method for analysing production losses from soiling caused by dust and dirt on the solar panels, which enables the plant operator to understand in detail which revenue losses are occurring in different parts of the plant and to plan cleaning operations accordingly.
We have been able to lay a fundamental layer in our systems that will enable us to extract data and analyze data and present solutions to the operators. It's a competitive advantage for us going forward.
This is something Scatec is very, very proud of, a fundamental layer where they can access all the data in all plants with very high quality. This is very rare, very seldom in this business to say they have high quality data, they can trust the data all across and use it together with research partners, etc., to develop new methods. Now another example. It's actually one of the success stories that Stefan presented. It's Johan Sverdrup. This is the most important industrial assets for Norway recently built. I guess you know, but Norway is an oil nation, and last year with the high energy prices, Norway had the same GDP as Sweden, even though Sweden has double the amount of people living in Sweden. So there's enormous financial revenues coming into Norway from these assets. And this asset here produces 30% of all that export. This is Johan Sverdrup. So this is one of the most important industrial assets for the finance of Norway and the future pensions. In this asset, Equinor has, together with us, Prediktor has built it, Equinor has the domain expertise, and we have built an information model to actually describe as good as possible the equipment structure in this asset. So this is, if you traverse this information model and the type system there, you will see something like this. It has the S95, OPC UA S95 information model as the basis. But it also has a 14226 ISA information model to describe all the equipment. So this is one of the, I would say, the more extensive information models I've seen with OPC Foundation. So this is more than 400 equipment definitions in this information model, describing everything that Equinor puts into their upstream oil and gas assets. And it's based on existing standardized semantics, and it's used now in more than 5 different assets with Equinor, and more than 5 different assets with AKBP, and also the third operator is now coming and using the same assets. So this is one specific information model used in mega big assets. This is the structure that we deliver based on this. So we have a cloud system that's the final destination for all this data, where Equinor build out all their IT strategies. They build this themselves. It's called Omnia. And then the core delivery from us is the Prediktor Industry Data Gateway. So this is the system in the IT network. It has more than 1 million real-time signals now. Again, real-time time series alarms and events. And this has 100% uptime since start in 2019. And this is important, of course, because this is a very important concept. Things like calculations of revenue, things they need to bill to the various clients when they export is going through this system. But it's a more complex structure than that. We also have what we call data interface gateways. So data interface gateways are communicating directly to the plant system. So these are in the plant network. They communicate to a lot of different, so this is more than 30 different plant systems. And different subsegments of those are captured by the data interface gateways. So by separating the gateway from the data interface gateways, you have a separation of security domains. So any with the access up here will never come down here. The only one that had access down here is the gateway, right? And all the load to the system stops from the client up here, stops at the gateway. The only load down here is the subscription this gateway have up here. So also separation of load. So this is kind of like important structural architecture to protect the plant systems to be running efficiently. But of course, there are dynamics to this. You saw all the 400 different type definitions. Equinor is updating those type definitions all the time. And they still like to use the new types while keeping the system up and running 100% of the time. So there's an underlying system here where you have model management, and you can update those models while the system is running. And then you have other dynamics. That's when they do maintenance on the real physical assets. There are updates to this in SAP. So SAP has like the truth of the current structure of the real asset. And then this system here, they work and they can then take in the dynamics from the model, from the real system, update this, and deploy this to the new system. So this is a redundant system, so you can deploy it to the standby system, and then the standby system will take over while it's running. So it's in full service all the time. And I would say also this more or less realizes, if you looked into this, Nomura open architecture is a diode. You cannot go down to the system from here. There's a reorganization of all the data so that services one specific information model and one endpoint for the system up there. So this is how we structure it IT-wise on these bigger deliveries we have. Now we're also into a kind of like a new interesting activity. So this is a research project we're running together with SNAP. SNAP is a hydropower operator in the Philippines. One of the bigger assets they have is Magat. So this is a hydropower dam. On this hydropower dam, they are now starting to put out floating solar. So this is the hydropower dam. You see the edge of the dam there. And they have one pilot floating ring there with solar. So they're going to build this. So this is 200 kilowatts. This is going to build this out to 60 megawatt floating on the dam. The many benefits of utilizing the surface on the dam, it's already there. You have the grid connection. You don't need to invest in a grid connection with the solar, etc. And they have also set up a larger 40 megawatt BESS battery energy system there. And they have the grid connection that connects all of this to the grid for supply. So the benefit of running this is a hybrid renewable asset. So one of the challenges when we get all these solar and wind power assets into the energy grids is that they are non-dispatchable. They are intermittent. But they're so cheap, so when they come into the grid, they will push out the gas power plants and the coal power plants because they're too expensive. And once those are pushed out and closed down, they will never be opened again. It's too expensive. There's a barrier price. So what happens is that the energy grid will have a more and more percentage of intermittent energy sources, and this is a challenge. But when combining this with a hybrid, you can cope with that. So let's say this is potentially the contract that Snap has with the TSO, the transmission system operator, for delivering energy. So this is like a base load for a large part of the day, firm power. It could be all other target curves. It could be dynamic with dynamic market conditions, but this is just an example. And then when you have the hydropower could produce like this to service this, but when you invest in solar, you put solar on top, and then you can save water. So when the sun is shining in the middle of the day, you save water. It remains in the reservoir. So you can use this at a later stage when prices are higher, whatever, by putting solar out there. But in order to then deliver according to the firm power specification here, you also need the BESS to cope with the more dynamic variations that the solar power causes. So this is a more complex setup. So when you have more complex setup like this, it becomes also more complex to operate. And to operate this, we are now building and developing an energy management system that will do optimization in real time, taking into account the various limitations of the assets design-wise, and the predictions on the weather, the varying market conditions, and doing a model-based predictive control of each specific asset and that, and then doing dispatch to the controllers to run all the different assets optimally. And again, here's a lot of real-time challenges and a lot of areas where we need standards and standard definitions down on the controller level, on the dispatch level, towards the market, towards the weather, etc., and towards the grid. So there's still a lot to do in order to get the standards in place, not only for operating the assets like I presented this morning, but also for the new things, the new scenarios coming in when we need to run the hybrid assets. So Prediktor is mainly a supplier of technical asset management systems, the gateways that service the IT/OT layer, and asset management on top of that to operate those assets. So, any questions?